Hi everyone, this is Mrs. GA and today we're going to learn about ellipses. So first I want to talk about the geometric definition of an ellipse. So an ellipse, it looks like an oval, so this is a shape called an ellipse. But by definition, an ellipse is a set of points in a plane whose sum of the distances to two fixed points, which we call the foci, is constant. So if you have any point on your ellipse and you find the distance to one foci and the other, and then you add them up, so let's call this D1 and we'd call this D2. D1 plus D2 is constant no matter where you set your point. So for example, if I pick this point, this distance plus this distance will be the same as this plus this. So that applies to any point on your ellipse. And that is the geometric definition of an ellipse. So now we're going to look at some ellipse equations and graphs. I do want to point out that today we are not going to be shifting any of our graphs, so everything will have a center at the origin. So a horizontal ellipse equation looks like this. Its form is x squared over a squared plus y squared over b squared equals 1. Now the really important thing to note here is that a is always considered larger than b. So in this case, our larger value is under x squared. Now, if you compare that to the vertical ellipse equation, it looks exactly the same, except the location of a and b are swapped. So a is still always considered the larger value, but when it is under y squared, that gives us a vertical ellipse. So that's the way you tell whether your ellipse is horizontal or vertical. You look at which whether x or y has the larger denominator. Also for the standard form, it should always be set equal to 1, and you should not have any coefficient for x squared or y squared. So let's start by talking about what these a and b values do. So you'll see if our center is at 0, 0, we have what's called a vertex at a0, so meaning the distance from the center to this vertex is a. So that's going to be a really important value for us. And you'll see that the distance to the left is also a. So here to here, the distance is a. So you use the value under x squared, you have to take the square root, and that will tell you how much to move left or right. And then whatever is under y squared, again, you take the square root, and then that will tell you how much to move up or down. Because if you see, this is called a covertex. The distance from the center here is b, and this distance is b. Now, perhaps the most important part of our ellipse is going to be the foci, or a focus to the left and the focus to the right. So the way that you find the focus is you actually have to use this little formula right here. C squared equals a squared minus b squared. And then, of course, so you can use these values, and then you take the square root to find c. So c is the distance from the center to each focus. So this distance is c, and from here to here is c. So a tells you the distance to the vertices, b tells you the distance to what are called the co-vertices, and c tells you the distance to the foci. Now, a few other vocab words you should know. The major axis is just the length. It's the distance from one vertex to the other. So notice if this distance is a and this distance is a, the length of your major axis is going to be 2a. And the major axis is always the longer axis. So in a horizontal ellipse, our major axis is horizontal, and you could guess our minor axis is vertical. And then you just find that by doing 2b. Now, if we look over here at the vertical ellipse, again, the only thing that's different is that our larger denominator is under y squared. We still call this value a squared. We still call this value b squared. So a is always the larger value. We also still find our c value using that same equation, c squared equals a squared minus b squared. Now here, again, since it's a vertical ellipse, you can see that our major axis is now the vertical axis because it's the longer one, and our minor axis is now the horizontal axis. So this is still 2a, and again, it's still a because a always is the longer value or the larger value, and our minor axis is still 2b. And then remember, this distance is a, this distance is b, and the distance from the center to the focus is c. So a, b, and c are going to be your really important values when you're working with these types of equations. Okay, let's try this first example together. So here we have the ellipse with the equation x squared over 9 plus y squared over 4 equals 1. So right off the bat, since I see that x squared has the larger denominator, I know this is going to be a horizontal ellipse, so I'm just going to sketch it in so I remember that our ellipse is horizontal. Also, looking at the equation, I can see that a squared is 9. Remember, a squared is always the larger denominator, which means our a value is 3. I can see that b squared is 4, which means our b value is 2. And then we have the formula that you just have to have memorized. C squared equals a squared minus b squared. So we have c squared equals 9 minus 4. So our value for c is square root of 5. So we can use these values to help us find all of these different things. So let's start with the foci. Remember, by definition, the foci, the distance from the center to your foci is c, and it is important to note that the foci are always on your major axis. So if you start at the center, and then you go to the right by square root of 5 units, you have one of your foci, and then the same thing to the left. If you go to the left root 5, you have your second focus. So our two foci are going to be at square root of 5, 0, and negative square root of 5, 0. So that's how we use our c value. Remember, our a value is by definition the distance from the center to your vertex, so along your major axis. So the distance from here to here is going to be 3. So that means that I have a vertex at 3, 0. And then this distance is also 3, so we have another vertex at negative 3, 0. And then our b value tells us the distance from the center to what's called a co-vertex. So it's along the minor axis, so this distance is b, which in this case is 2. So that means that this point would be at 0, 2, and this would be at 0, negative 2. So sometimes you're asked to find what are called the co-vertices, but in this case we only need the vertices, which are on the major axis. So now all we need to find are the length of your major and minor axes. So again, the major axis is always the longer one. So in this case, it's the horizontal axis. So if we know that this distance is 3 and this is 3, the total length is 6. Or you could remember that it's 2 times a. Your minor axis is always 2 times b, or we know that that distance is 2 and this distance is also 2. So the length of our minor axis is 4. And there you have it. So again, the first thing you should look at is whether you have a vertical or horizontal ellipse. That can be determined by finding which denominator is larger. And then you should also remember this formula, c squared equals a squared minus b squared, because that will help you find your foci. Okay, let's try one more example together. So here we have the equation x squared over 16 plus y squared over 25 equals 1. So in this case, you can see that our larger denominator is under y squared, so that means that we have a vertical ellipse. So it looks like this. Now, in this case, again, I want to reiterate, a squared is always the larger denominator. So a squared is 25, which means that a is 5. B squared is 16, which means that b is 4. And then we can do c squared equals a squared minus b squared, the formula that's associated with an ellipse, and we get c equals 9, or c squared equals 9, so c is 3. So in this case, you can see that since we have a vertical ellipse, our foci are going to be actually above and below your center. They're going to be along your major axis. So again, we know that the distance from the center to your focus is 3. So this distance is 3, which means your foci will be at 0, 3, and 0, -3. Now your vertices, again, are going to be here and here, and it's going to depend on the length of A. So this length, the entire, the distance from their center to the top is our A value, which is 5. So we have a vertex at 0, 5, and 0, -5. And then we could also find our co-vertices because we know that this distance from the center to the right or left is 4. So our co-vertices would be 4, 0, and -4, 0. And now to find our major axis length, again, it's this entire vertical axis from top to bottom. So it's just 2 times your A value, which is 10. And then our minor axis, in this case, is the horizontal length from here to here. So 4 plus 4 is 8. And there you have it. Okay, so go ahead and pause the video and see if you can find the following information for this equation, and then we'll check your answer in just a few seconds. Okay, so go ahead and check your answer here. Again, as soon as you see that x squared has the larger denominator, you should be able to tell that this is a horizontal parabola. So here, a squared is 16, so a is 4, b squared is 9, so b is 3, and using the formula, we can find that c is root 7. So again, c is the distance from the center to the focus, so we have 2 foci at plus or minus root 7, 0. A is the distance from the center to your vertices. So from here to here is 4, from here to here is 4, so that's where our vertices are. This is our major axis, so it's double the A value, which is 8, and this is our minor axis, which is twice the B value, which is 6. And again, you could also name the co-vertices. They would be at 0, 3, and 0, -3. Okay, so let's try another example together. So here, we're asked to find the foci of this ellipse. So you might notice that this is not in that standard form. So that's going to be our first job, is to make sure it looks like those equations from our second slide. So the one thing you should hopefully notice is that our equation is always equal to 1. So to set this equal to 1, we actually divide both sides by 144. So that's going to be your first priority, to always set your equation equal to 1. So that actually gives us x squared over 9 plus y squared over 16 equals 1. So now you can see that we have a vertical ellipse like this. I know it's vertical because the larger denominator is under y squared. Again, since this is a squared, we know that a is 4, so this would be 0, 4, and 0, -4, because remember, the a value tells us half of the major axis, or the distance from the center to your vertex. And since b squared is 9, we know that b is 3, so this would be at 3, 0, and this would be -3, 0. Remember, b is the distance from the center out to the left or right for a vertical ellipse. And then we need to use our formula to find c. So c squared equals a squared, which is 16, minus b squared, which is 9. So c equals the square root of 7. Again, since it is a vertical ellipse, our foci will be here and here, and the distance from the center to each focus is root 7. So our foci, which is what they're asking us to find, are actually at 0 plus or minus root 7. or of course you could list them both separately. All right, so go ahead and pause the video and see if you can find the foci of this ellipse. Also, sketch a graph. It should be relatively accurate, like you should be able to name the coordinates of your vertices and co-vertices. All right, go ahead and check your work. So hopefully the first thing you did was you divided both sides of your equation by 36 to put it into standard form. So once it looks like this, you can see, okay, this is a horizontal ellipse. The distance from the center to the right or left is 3 because your A value is 3. The distance from the center to the top or bottom is 2 because your B value is 2. And if you use the formula c squared equals a squared minus b squared, you find that your c value is root 5. Remember, c is the distance from the center to your foci, which are always on your major axis. So here we have two foci, one at positive root 5, 0, and one at negative root 5, 0. So you can list them separately or write them like this. Either way is fine. Okay, so now we're going to try to make an equation of an ellipse given different pieces of information. So here we are told that the vertices of an ellipse are at plus or minus 4, 0, and the foci are at plus or minus 2, 0. So before I even sketch it out, I know that this is going to be a horizontal ellipse because our vertices are always along our major axis, and so are our foci. So let's say here's 4, 0, and negative 4, 0. And then we have 2 and negative 2, 0. So these are our foci. So since our vertices are at 4, 0 and negative 4, 0, that tells us that our A value is 4, which is going to be important because we need to find A and B to make our equation. Now, the other piece of information we have is actually C. So remember, C is the distance from the center to your foci. So we know in this case that C is 2, but we are still missing our B value, which we need for our equation. And again, we found C because that's the distance from the center to your to each focus is C, which in this case is 2. So to find B, we still have this equation, c squared equals a squared minus b squared. So we can solve for B using this little formula. So 4, which is c squared, equals 16 minus b squared. So then we get b squared equals 12. And just so you know, our A and B values, and our C value is always going to be positive. So we just take the positive square root of both sides and we get 2 root 3. So again, that's our B value, although we actually need B squared for our equation anyways. So here we could actually just use this and plug it in here. We know that A is 4, so A squared is 16. So our final answer will be x squared over 16 plus y squared over 12 equals 1. And there you have it. Okay, go ahead and pause the video and see if you can find the equation of the ellipse that has vertices at 0 plus or minus 6 and foci at 0 plus or minus 4. Okay, so go ahead and check your answer here. Since our foci and our vertices are vertical, we know that this is a vertical ellipse, so it's going to have this form. So note for this equation, the larger a squared term should be under y squared. So because we know that the vertices are at 0 plus or minus 6, we know that the distance from here to here is 6, which is our a value. So a squared is 36. Since we know where the foci are, that tells us what our C value is. Remember, the C value is the distance from the center to your focus. So we know that C is 4, but we're still missing B, or more specifically, B squared. So we can find it using this formula, C squared equals A squared minus B squared. So I substituted C squared with 16 and A squared with 36, and it allowed me to find that B squared is equal to 20. So this is what your equation should look like. Okay, the last thing we're going to talk about is what's called the eccentricity of an ellipse. So this is the eccentricity helps us kind of to determine whether our ellipse is going to be more circular or more ovular, and we determine that by comparing the ratio of the distance to the focus and the distance to your vertex. So you can see here that when our C value is really small, but our A value is large comparatively, we have more of a circular shaped ellipse. But when our C value and our A value are much closer, we have a more stretched out, a more narrow ellipse. So the way you calculate what the eccentricity is, it's simply your C value over your A value. So we know that C is always going to be smaller than A no matter what, because C is inside our ellipse, right? It's the distance from the center to your focus, so it can never be outside your ellipse. So again, this value should always be somewhere less than 1, but it should also be more than 0. But general rule of thumb, the closer your eccentricity is to 0, that means that your C value is much smaller than your A value, so it's more circular. And if your eccentricity is really close to 1, that means that your C value is closer to your A value, so you get a much more narrow graph. So again, the eccentricity just helps us to see what the general shape of our ellipse will be. So here we have one last challenge problem that we're going to do together. So here we're asked to find the ellipse, the equation of the ellipse that has foci at 0 plus or minus 8 and an eccentricity of 4 over 5. So since we have foci that are along our vertical axis, we know that we are going to have a vertical ellipse. And then here is one focus, and here's another one. So this is at 0, 8, and 0, negative 8. So again, right off the bat, we know that our equation will be in the form of x squared over b squared plus y squared over a squared equals 1. So since it's vertical, our a squared value should be under y squared. So we do know, we only know one thing from the focus. The focus tells us that our C value is equal to 8, because remember, C is the distance from the center to the focus. But the eccentricity, remember, eccentricity is the ratio of C over A. So here, since our eccentricity is 4 over 5, we can say 4 over 5 equals C over A. And we know that our C value is 8, so we can say 4 over 5 equals 8 over A. So if we cross multiply, we get 4A equals 40, so A equals 10. So we have found our A value, which we'll use in our formula, but we still need to find our B value, which we can find using our other formula, C squared equals A squared minus B squared. So 64 equals 100 minus B squared. So we end up with B equals 6. So now that we know A and B, we can simply plug them into our formula to get our equation. So we get x squared over 36 plus y squared over 100 equals 1. And there you have it. Okay, that is all for today's video. Thank you so much for watching.